Okay, now we're going to look at factoring a perfect square. So a perfect square numerically is something like the number 4, which equals 2 squared, or 36, which equals 6 squared. So any number who has where its square root is a natural number is called a perfect square. Okay, so a whole number. So another perfect square would be 25 because its square root is 5. In terms of quadratics, we call anything that can be written like this, x plus or minus h squared, we call that a perfect square. Okay? So here's a more complex looking one like this. Now, if we just think of the plus for now, the minus will come later. So if you expand something like this, x plus h all squared, you will get it in this form. Let's take a look at this first. Okay? So any quadratic expression that factors to x plus or minus h squared or ax plus or minus h squared is called a perfect square. So if it factors to that, it's a perfect square. Okay? Let's take a look at x plus h. X plus h is squared is x plus h times x plus h. Okay? So let's take a look at this. When we expand it out, first term gives me x squared. Middle term is going to be xh plus xh. Sorry, xh plus xh. So instead of being like the difference of squares where these cancel out, they're the same sign, so they actually double. Okay? And then the last term is h squared. So kind of like the difference of squares, except for the middle term doesn't go away, it doubles. And there's no minus in there for this one. If that was a minus h here, that would be minus, and that first, instead of plus 2h, that would be minus 2h there. And you can check that by multiplying out x minus h squared. Okay, so since that, then any quadratic that is in the form x squared plus 2h times x plus h squared must factor to x plus h squared. So we just verified that by multiplying this out. We get that form. So anything that looks like this must then be able to go backwards to that. Okay? Similarly, if you had something that looks like this, okay, then it looks like this. This is a nice way of looking at it. Instead of treating it as a squared x squared, like we have up here, if we put the ax together and square it, it's like ax is the new variable. Okay, so ax is the thing that we're factoring around instead of the x. And then we still have a 2h right here out in front of the whole thing. So the 2h is the same for both. Okay? So basically the pattern that we're looking at here is if we see a quadratic where if we take half of this number, half of 2h is h, if we square half of the number there, which is h squared, we get this. Anything where half this number squared is equal to the constant term is going to be a perfect square. Same here. Half this number squared is the constant term, we have a perfect square. Okay? So this type of form, though, will factor to ax plus h all squared. Okay? So notice that the number in front of the x term, which is here the 2h, or ax, which is 2h, is 2h, and the last constant term is h squared. This is the condition. Okay, so this is the condition to check to determine if you have a perfect square. Make sure that half this number squared is that number, or the square root of that number times 2 is that one. Okay, so let's take a look at some examples here. Take a look at this one. So x squared minus 18x plus 81. Well, what's half of 18? Half of 18 is negative 9. Negative 9 squared, okay, is 81. So 9 times 9 is 81. Negative 9 times negative 9 is going to be 81. Okay? So that is x squared minus 2 times 9 times x plus 9 squared. So h is the 9. Okay? So like we had up here, the h is 9 in this case. Okay? So because we have that, this factors to x plus or minus h all squared. Because there's a minus here, we're going to put minus there. Now you can check that by expanding that out. So x minus 9 times x minus 9. Check to see if it gives you that. Okay. Here's another one, a little more complex now. Is there a common factor? No, there's no common factor for this one. So I'm going to rewrite this as some entity squared here plus some number times that thing plus 9. Okay, so 16y squared is the same as 4y all squared. Now because I'm putting 4y here, I need a 4y right there. Okay, so just as we had in here, if we have ax there, we need an ax here. That ax is 4y. So if I put a 4y there, 4y times what is 24y? Well, 4 times 3 times 2. So 4 times 6 is 24, but we need to break this into 2 times something, so 6 is 2 times 3. And then plus 3 squared. The other way you can fill in this, if it's a perfect square, the square root of this number should be there, and the square root of this whole thing should be here, times 2. If that's true, if this is that, then you have a perfect square, and you take 4y plus 3 all squared is factoring it. Okay? So you might want to multiply this out just to check, see if you see that pattern. Okay. Couple more examples. So 3x squared plus 6x plus 3. Well, hope you notice first of all that you have a factor, common factor of 3. So you take that out. Okay. Now, what's half of 2? Half of 2 is 1. 1 squared is 1. So this is a perfect square. Okay, so you can write it like this. You don't have to write this step. Once you know that this is a perfect square, you can just jump right down to here. But you need to recognize this pattern. Half this number squared needs to be this number. Or the square root of this doubled is that number. Okay, and then you can write this as factored like that. Another one, 40k squared minus 120k plus 90. Well, you definitely know that 10 is a factor of that. So factor out the 10, and then you have no other common factor. So rewrite this as a perfect square form. So 2k all squared. And I have a 2k in here then. And I got 3 squared there. That's 9. So I'm going to need a 3 here, and that's 2. Does this work out? 2 times 3 times 2 is 12. So that's true. So we have a perfect square that we can write like this. 10 times 2k minus 3 all squared. Next one. Now we have some more variables in here. Okay, so can I write this in that proper form? Well, let's take a look. X squared stays the same. Okay, square root of 25y squared. Well, it's 5y. I have an x. Is this true? 2 times 5y is 10. 10y times x is 10xy minus. So because half of this number here squared, so half of negative 10y is negative 5y. You square it, you get 25y squared. Okay, so there we get that to be factored to that. Now, here's where we have numbers at the front and the end and variables. can we write this in the proper form? Well, let's write the first and the last term first. Okay, so without looking at the middle term, 2y squared and 5x squared. So we need the 2y and the 5x in the middle. Okay, and then we need to double it. So the 2y is there, the 5x is there. Double it. Is this true? 2 times 5 times 2 is 20. X times y is xy. So this is true, this equality here. So now we can factor it to that. And that's it for perfect square.